Welcome to Episode 30, Azure Networking Basics, where we frame networking as the quiet substrate that lets every application breathe. Networks are not only cables and routes, they are the pathways that carry identity, data, and control between components. When the substrate is healthy, applications feel fast, predictable, and secure. And when it is not, even perfect code stumbles. A good cloud network provides clear boundaries for traffic, simple rules for access, and dependable resolution for names and services. Think of it like a city plan: streets, signs, checkpoints, and emergency lanes all working together. The practical goal is to make data flows easy to understand and easier to audit. By learning the basic building blocks, you gain the confidence to design layouts that scale without chaos and absorb change without breaking habits. A virtual network is your private address space in Azure, and address planning is the first decision that shapes everything that follows. You choose one or more ranges using common private address blocks and reserve space for future growth before deploying anything. Good plans prevent overlap with on-premises sites or other cloud environments, because overlap turns simple routing into a tangle of exceptions. A helpful practice is to leave generous room for additional subnets, new environments, and test areas that mirror production. If you must connect multiple networks later, clean ranges make that connection routine instead of stressful. Documenting the plan, ranges, purpose, and ownership keeps teams aligned. Addressing is dull when done right, but it is the quiet foundation of painless connectivity. Subnets divide a virtual network into segments with distinct purposes, and they carry policy with them. A subnet can host application servers, database tiers, or shared platform services, creating natural boundaries for security and routing. Service endpoints, and their successor, private endpoints, let resources in a subnet reach platform services through trusted paths rather than the public internet. Segmentation matters because it narrows the blast radius of mistakes and isolates sensitive components from casual traffic. For example, a database subnet should not accept traffic directly from the internet or from developer workstations. Clear names like app front, app mid, and data help everyone understand intent. Subnets turn a flat space into a structured neighborhood where rules can be applied predictably. Network security groups provide allow and deny rules that act like stateless firewalls at the subnet or network interface. A network security group, which we will call NSG, evaluates ordered rules against 5 simple ideas: source, destination, protocol, port, and action. Start with a default deny mindset and then open the minimum ports needed for the workload to function. Small mistakes, like allowing all outbound to everywhere, usually appear months later as surprise dependencies, so be deliberate. Use application tags and service tags to simplify common targets without hard-coding addresses. Apply NSGs at the subnet for broad policy and on specific interfaces for exceptions. Regular reviews keep the rule set tidy, readable, and aligned to reality. A route table tells packets which next hop to use, letting you steer traffic around appliances, gateways, or inspection points. Azure provides system routes by default, but user-defined routes override them when you need custom behavior. Common patterns include sending internet-bound traffic through a firewall or directing private service traffic through a virtual appliance. Avoid unnecessary complexity. Too many specific routes create maintenance burden and increase the chance of black holes. Test path changes carefully, because a single wrong prefix can redirect entire environments. Pair route tables with clear diagrams and comments that explain the why, not just the what. When teams share that context, troubleshooting becomes faster and far less contentious. Name resolution keeps services discoverable without memorizing addresses, and Azure DNS provides authoritative hosting for public and private zones. Public zones map friendly names to public endpoints, while private zones resolve names inside virtual networks without exposing them to the internet. Consistent naming conventions matter. They hint at environment, region, and role, making automation simpler and incident response quicker. For hybrid setups, conditional forwarders and linked virtual networks let on-premises resolvers and cloud resolvers cooperate smoothly. Avoid mixing ad hoc host files or hard-coded addresses in applications. Let DNS carry the responsibility. When name resolution is predictable, deployments move faster and rollbacks are safer, because changing an alias is easier than touching code. Private endpoints and private link bring platform services like storage and databases into your private address space. Instead of reaching a public endpoint with broad exposure, your resource connects over a private interface inside a subnet. This reduces attack surface, simplifies compliance reviews, and removes dependence on internet egress. The trade-off is planning. Each private endpoint consumes addresses and must be reachable through your chosen routing and NSG rules. Map which services need private access and group them logically to avoid fragmentation. Test access from the places that matter: application hosts, jump boxes, and diagnostics tools, so there are no surprises on release day. Private connectivity turns shared services into neighbors rather than strangers across the public frontier. Virtual network peering stitches networks together with low-latency, high-bandwidth links that feel like a single fabric. Regional peering connects networks in the same region, while global peering bridges regions with similar transparency. Peered networks do not require gateways, and bandwidth scales with the platform, which keeps performance steady. However, transitive routing is not automatic. If you need traffic to pass through shared hubs or firewalls, design a hub-and-spoke pattern deliberately. Use careful naming and tagging so peers are obvious, and keep routable address spaces unique to prevent conflicts. Peering is simple to set up, but its simplicity demands discipline to maintain clear, auditable paths as environments grow. A site-to-site virtual private network gateway provides encrypted tunnels between on-premises networks and Azure. It uses public internet paths but protects traffic with established standards and keys. This approach is practical for first connections, branch offices, and moderate throughput needs. Plan for redundancy by building active standby or active-active configurations on both sides, and monitor tunnel health so failover is visible, not mysterious. Keep key lifetimes, allowed subnets, and encryption settings documented and aligned with security guidance. When a tunnel drops, predictable configuration speeds recovery. A site-to-site gateway is the bridge that turns Azure into an extension of your existing network rather than a separate island. ExpressRoute offers private, dedicated connectivity into Microsoft's backbone, bypassing the public internet entirely. It improves predictability for latency and throughput, and it reassures auditors who prefer non-internet paths for sensitive data. Circuits come in tiers and can connect to multiple regions for resilience. The cost and lead time are higher than a virtual private network, so many organizations begin with a tunnel and add ExpressRoute when traffic or compliance demands grow. Designed for dual circuits and dual peering locations to avoid single points of failure. Treat the link as a critical utility and watch utilization trends. When private links carry the load, application performance feels steady regardless of public internet turbulence. Azure offers two families of load balancers that shape how users and services reach your applications. Layer 4 options route based on addresses and ports, enabling fast, scalable distribution for virtual machines and container backends. Layer 7 options add application awareness, path-based routing, headers, and web application firewall features to protect and steer traffic more intelligently. Choosing between them depends on where logic belongs: simple port spreading at Layer 4 or content-based rules at Layer 7. Health probes keep only healthy targets in rotation, and connection draining preserves user sessions during maintenance. Load balancing is less about gadgets and more about smooth experience under change. A firewall and a web application firewall add inspection and protection at different layers. Azure Firewall centralizes outbound and inbound filtering with application rules, network rules, and threat intelligence feeds. A web application firewall sits in front of web apps to block common attacks like injection and cross-site scripting by understanding HTTP semantics. Place these controls where they see the right traffic: a hub firewall for central egress and a web application firewall at the edge for public sites. Keep rule sets updated and review exceptions on a schedule so temporary allowances do not become permanent gaps. Defense in depth works best when each layer has a clear job and minimal overlap. Monitoring turns invisible flows into actionable signals, and NSG flow logs provide a record of allowed and denied traffic at the rule level. Pair them with traffic analytics to spot top talkers, unexpected destinations, and noisy rejects that suggest misconfiguration. Network Watcher offers connection checks and topology views that help during change windows and incidents. Standardize diagnostic settings so every new subnet, gateway, and balancer emits telemetry to the same workspace. Alert on policy denials, sudden route changes, and drops to critical services so you learn about issues before users do. Observability is the habit that converts guesswork into calm, repeatable fixes. A baseline Azure networking blueprint ties these essentials into a simple, scalable pattern. Start with generous, non-overlapping address spaces per environment. Carve clear subnets for front ends, application tiers, data, and shared services. Protect them with NSGs that default to deny. Route internet egress through a central firewall and use private endpoints for platform services. Connect environments using hub-and-spoke peering. Bridge on-premises networks with a virtual private network or express route, and expose applications through appropriate load balancers and a web application firewall. Wrap the whole design with consistent DNS, logging, and alerts. With this blueprint, growth becomes a matter of repeating known shapes rather than inventing new ones under pressure. Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.